Yeah, I think that's just about everyone. So if we just kick off from here, so just start off, thanks to everyone for coming around tonight, and obviously thanks to the community. This is our I think it's our 5th online meetup now, so it's really gathering some steam, and there's more and more almost every week. So it's
many couples have a wedding day plans ruined by the.
For those of us who don't know us, Charlotte and I work for IO Associates. That's a specialist tech recruitment company based in Bristol. Myself, I do contract, and Charlotte does perm. And you may see our details on LinkedIn. So if anyone does have any recruitment related questions afterwards, or want to speak to us about the market, or just any CV feedback, feel free to drop us a line afterwards. We organise as a business .NET Meetups in London, in Reading, Cheltenham, South Wales now as well, and we also sponsor .NET Southwest. So if you'd like to find out about any of those meetups, you can find them online. Our next event is actually on Tuesday. You can see it on the meetup page. That's .NET and that's TDD and the Terminator with Layla Porter. And then we'll be hosting John Skeet on the September the 3rd. So details launch on our LinkedIn page. So sign up to that soon. You can have a look. Just a bit of housekeeping for everyone. Just if you can keep yourself on mute whilst Ian presents, and then there'll be time at the end if anyone wants to stick around for a chat. Ian, I didn't know how you wanted to play things. Did you want to answer questions as we go along via the chat box, or did you prefer to do
I think it's kind of easiest online to do it at the end, because I won't be able to see the chat bot, and I think rather than interrupting my flow, I've got quite a lot to get through, and I'm not. This is a new version. I've not timed it before, so let's do it at the end.
Cool. Okay. Well, in that case, guys, if you just keep yourself on mute, save your questions to the end, and then without further ado, here's Ian.
All right, everybody, I'm going to switch cameras, so I'll vanish for a bit and then turn on some slides. Hopefully you'll see one or the other. Do yell out if you get the presenter view of the slides or other such usual nonsense that seems to afflict us in the modern world. Right, so you should get some slides. Let me try and switch presenter view. All right, hopefully. Are you seeing the kind of human being view rather than the presenter view?
No, presenter view.
You're seeing presenter view, all right. Are you now seeing the human being view?
Yes.
That's one.
Just alter where I am. I can see that. Okay. And can you see me?
Yes.
Yeah, we can see it.
Technology. All right. So what I wanted to talk to you about tonight, I wanted to talk to you about a talk I did a long time ago called TDD, Where Did It All Go Wrong? And I wanted to talk to you about, I don't know, how I might present some of the ideas today, because I think they are still fairly relevant. So it's been 7 years since I gave that talk. Who am I? Most of this is fairly dull. I've been doing this for a while. The point I raise is always the one at the bottom. I'd always encourage people to speak. I got started in about 2002 when I started London User Group, and we didn't have anybody to speak because it was right at the beginning of the early days of .NET. So we had to kind of all agree who was going to do something next week and do those lightning talks, and it got me over the hard bit. But I find learning to speak professionally well, not professionally, but to tech audiences is very useful in the whole model of see one, do one, teach one, and let's clarify and organize your thinking. And in better times, you used to get to travel to nice places. Nowadays, you just get to do it from your front room. For those of you who are .NET developers or Python developers, I work on a project called Brighter. So Brighter is both a command dispatcher in the sense that effectively it takes a command and it finds a handler for it. But also it can do that out of the process as well as in process over a range of messaging transports, RabbitMQ, SNS and SQS on the AWS platform, for example. We have a C# version, and we also have a version for Python. And there's a corresponding, if you're into CQRS, query model for doing the query side. As I said, back in about 2002, I was one of the founders of London.NET User Group. We've switched slightly in the pandemic. Our meetings have moved to more of a open spaces style model, and we hope to run another one in September. Follow us on Twitter, and we will share information about that. Okay, so let's talk about what the agenda is. So what I'm going to talk about first of all, and what I think of as the fallacies of TDD. What are the things that most people think are true about how we practice test-driven development that are wrong and have actually led us down quite a negative path in terms of our practice? That's the bulk of what we're going to talk about tonight. We'll then have a little bit of a review of Red-green-refactor. There are a couple of nuances in there that I think are worth just kind of drawing out. Actually, after that, we're going to skip to clean architecture. So there's no behavior indicators covered elsewhere. Sorry, I need to change the slide. Look at clean architecture. We talk about hexagonal or Portion adaptive architecture here, but clean architecture is a good modern equivalent of that. We'll talk about why that helps in a test-driven environment. And then finally, very briefly, we will make you aware of some principles of TDD that Kent Beck advertises nowadays. So as I say, I first gave this talk back in 2013 at NDC, and by that stage, I've been doing TDD for close to 10 years, not quite that much. So I'm on that user group, thanks to Benjamin Mitchell. We've really quite early on embraced TDD in about 2004, and so we've been practicing for quite a while. And I noticed that there were significant problems with the results of TDD that we were encountering. And I remember going online and saying to people, is it a problem that I have 3 times as much test code as I do production code? And that was a system where we launched into production with 0 defects, and we ran for months with no defects because of the test coverage we had in that system. But it felt to me that this idea that we were going to run 3 times as much test code as production code was potentially a problem. And certainly in terms of cost, that was an issue that was raised against us. People started to say things like, you know, you're risk averse, you're not productive enough. And that was an open question. How can we remain productive if we were doing TDD? And the other thing that began to happen to us was we noticed that our test code bases were very fragile. So for reasons which are best left to history, we had to write essentially our own ORM wrapped around the data store that we were using at a prior gig that I was at. And this thing was heavily TDD'd, but the problem was whenever we made changes, we noticed that hundreds of our tests, not just one, would fail quite often. And it wasn't that we'd actually changed the behavior. If we made a correction or a fix, we still saw breaking tests. And a significant proportion of those breakages were down to our use of mocks, basically to check the behavior. So I began to question why we ended up here. Refactoring has become difficult, tests have become expensive, and although we get results, those results have come at a problematic cost, which maybe we don't want. So I started to go back to read Kent Beck's original book, Test-Driven Development. I read that very early on, but I probably haven't picked it up much in those last 10 years, and I had read other people who effectively followed on and given their accounts of how you do TDD. And if you go and look at Amazon, one of the things you'll find about this book is it gets some poor reviews. People start looking at it going, I really don't understand what he's talking about. It's a very poor introduction. The amazing thing is, if you go back with 10 years of experience, you discover that this is an amazing book that Kent really understood test-driven development. And many of the questions I had 10 years later, he already knew the answers to. And it's important to understand that at this point, Kent, who started it in Smalltalk, have been doing test-driven development for quite a while. And some people, I think, for example, don't understand that he knew about mocks, he knew about refactoring to patterns. Things that I thought came much later in the journey of TDD had already actually been decided by people working in environments where this was not an advertised kind of practice, people like the C3 group. So it's a book that's worth returning to, and a lot of my talk is really based upon my rediscovery, if you like, of what Kent had been saying all along about TDD, but most of us have missed. All right, so let's talk about the fallacies of TDD. What do we tend to get wrong? Okay, the first, and I think perhaps the most important fallacy of TDD is this idea that developers write unit tests. And unfortunately, nothing is further from the truth, right? And the real problem with that statement is the second half of that statement, unit tests. There are no unit tests in TDD. And it's very clear if you read Kent's book that he refers to unit tests only once, and that is mainly to say that essentially you are not doing unit tests. Everywhere else, Kent refers to tests. In the early noughties, the TDD community created words like programmer test or developer test to identify what we were doing, but it was very clearly never unit tests. And that leads to the most significant problems that we have in TDD today, this confusion around the idea that developers are writing unit tests. So Kent essentially said, I call them unit tests, but they don't actually accept the definition of unit tests very well. And in fact, he does occasionally verbally call them unit tests, but even he had begun to move on. The problem is effectively drawn out by the Wikipedia article on unit tests. And as you can see, it says, substitutes such as method stubs, mock objects fakes, and test harnesses can be used to assist testing a module in isolation. And the use of the word unit test brings in this idea that the thing that is under test, sometimes called the SUT or system under test, must be isolated. And this refers to the way that classical testing would tend to say there are modules and we unit test those modules, test that module in isolation. We combine those together effectively and have an integration test to say what happens when we plug this module into that module, which it has a dependency on. And then essentially we say there's a system test which has the whole thing working. And the goal was essentially defect localization. The idea would say, well, if I test this module in isolation, I will be able to tell what the problems are with this module, as opposed to problems for integrating these two modules. And what that led to was a pattern of behavior in a lot of testing, which originally in the community under unit test patterns by Jared Mazaros was identified as need-driven development. And need-driven development is this idea that became prevalent that I need to mock all of the dependencies of my class in an object-oriented environment. So when I'm doing OO, I'm thinking of myself as saying, I want to essentially just test this class in isolation, and I will mock every dependency. And people were terrified of doing any kind of new in a constructor. Everything had to be injected. Everything had to be an interface. It was bad design not to have an interface. It was bad design not to inject things. People would complain and say, oh, this third-party framework or library I'm using doesn't have an interface. I can't get it under test. This is a disaster. You failed us as a community, right? And this kind of attitude became prevalent, and people wrote books around TDD, identifying it as unit testing, identifying the constraints for TDD as being the constraints of unit testing, and nothing is further from the truth. You do not follow these rules when you are doing TDD. And one of the problems this has led to is a huge dependency in places like Java and .NET on inversion of control containers. Because everything now has dependencies, and because those dependencies are a web of, well, my dependency has a dependency on this thing, which when it's concretized has 2 or 3 dependencies, which each in turn concretized have 2 or 3 dependencies, you end up needing the services of an IOC container because the chain is never ending. And you don't want to try newing that up yourself in the composition route. But the reality is, if I remove that constraint about unit testing and I said, well, the only really valid reasons for injecting something into a class is if I'm really looking at the open-close principle that says, I want to be closed to modification but open to extension. In other words, the code in here has an algorithm that I've tested, but I need to extend it because I have multiple variants. This code runs my overall workflow for doing insurance underwriting, but actually depending on the policy, I load up a different algorithm. And that's a domain-based decision, right? But otherwise, there's no reason why you shouldn't be newing things up in a constructor. That's what they're for, resource acquisition as initialization, right? So this idea we've got into that I inject everything has become a problem. And if you throw that away, you throw away the idea that I need to essentially isolate all of the dependencies of a given class for testing. One of the things you'll find is it's much easier to go for poor man's DI, which is really manual composition of the root. And you get back to the main reason that you want dependency injection. And the reason you want dependency injection is really layer boundaries. When I have layer boundaries, essentially I have some notion of depends downward, or in modern clean architecture depends inwards. And that means that an inner layer is where I need to do something that's in an outer layer. For example, say I need to fill in an iRepository with an actual repository instance that talks to a given database, because that's an adapter on the outside. Then essentially I will need dependency inversion to say at runtime, here is the concretized version of that type whenever you want to ask for one. But certainly the amount of IOC we have today is a consequence of poor thinking about testing. Back in 2007, I wrote this when I used to blog over at CodeBetter. Mocks replace all the dependencies, leads to fragile test, overspecified software, and behavior sensitivity. So this is what I was finding at the time. We had fragile tests. I would go in and I would say, hey, I need to change some of the implementation code for how this stuff works. Oh, and you know what that results in is me changing this class I depend on and its interface, which means that all the tests break because I'm no longer actually the expectations I set up for this mock that I was going to be passed these parameters in this order no longer hold true, or essentially I don't call that interface anymore, I call another one. Any change of those kind of details resulted in a wave of broken tests. We knew too much in the test about the implementation details, this idea of overspecified software. And quite often you would find you wrote tests that essentially the entire implementation was pre-given to you by the test. In the test, I had to go through and say, well, I'll call this method and pass these parameters. I'll call this method and pass these parameters. And actually that became a goal. Some people's goal was to write their software in this need-driven way and say, hey, the things I depend upon, their interfaces will be governed by the requirements I established through this test. And that made testing incredibly painful. It took a long time to write one of these tests because I was literally figuring out the implementation when I was writing the test. The test shouldn't understand the implementation. It just understands the behavior it's trying to drive. Mazoris calls it behavior sensitivity here. It's actually, we get into a strange world with different people and their concept of what behavior means. What he means is that we are sensitive to how we call other systems as part of our response to filling in a given test, right? Not to the behavior we are trying to get under test. That's important to understand that later on. But this problem was gaining currency. And we saw people at the time saying, oh, well, what you need to do is stop using strict mocks. You need to use mocks that replace components that are not strict because you don't verify they were called. They just act as a fake at runtime and replace stuff. And indeed, Mazoris comes up with this thing called test double, which is any kind of replacement we're using at runtime for essentially a dependent upon component. But we began to really struggle against our own use of mocks. And back in 2019, so literally recently as a year ago, Ken made the following point, right? Tests should be coupled to the behavior of the code and decoupled from the structure of the code. What we mean by that, right? So what we mean is that your tests should be oriented around what is the requirement that I'm testing for and not about how have I implemented it. I should be able to change the implementation details of the software I'm writing and no tests should fail. Indeed, this is the whole principle behind refactoring. So Martin Fowler, who wrote the book on refactoring, is one part of the original C3 team, people like Kent Beck, from which much of our agile practice develops. He wrote this: changes made to the internal structure without changing the observable behavior. That's the definition of refactoring. So it should be possible for me, for example, to decide that the sorting algorithm I'm using is not as efficient as it could be, entirely replace that sorting algorithm and no tests fail. It should be possible for me to replace the search algorithm and no tests fail. It should be possible for me to decide I'm going to call the database differently or even use a different database and no tests fail. It should be possible for me to decide that I'm not using a database at all and no tests fail. But what happens is we couple our tests so highly to implementation details that it's almost impossible to refactor. If you have a code base today where you surmise that if you went in and you completely rewrote the internals of a class, threw everything away, just deleted it all, and then rewrote it from scratch, your tests would fail, then you've done TDD wrong. Because Refactoring should allow you to entirely replace the implementation with something else, and provided the behavior you express is correct, then it should continue to work. And this notion of unit testing, this idea of replacement with mocks, has completely derailed TDD and led to most of the problems we have with it today. If a program's behavior is stable, no tests should change in response to us making an underlying change to the implementation details. And we'll see when we look at Red-green-refactor later quite how important that becomes, but really this idea is key, that you're testing a given behavior, and when you test that behavior, you shouldn't change implementation details. Now, well, you should be able to change implementation details. One of the things that I've seen at some points is people using the presence of mocks as a way of enforcing certain standards or guidelines. They'll say stuff like, oh, well, the junior developers keep leaving out transaction boundaries. So I will write a test which makes sure that they create and they destroy a transaction, or they adhere to our style guidelines. Look at me, clever senior developer. I have essentially forced my juniors to behave in the way I expect. Woohoo, stop doing that. Okay? That's really arrogant and unpleasant. Your implementation code is not a mechanism, your tests are a mechanism to enforce coding standards. Work with people, review their code, educate them, but don't use tests as a policing method to try and force behavior on junior developers. Okay? Because you don't necessarily know as much as you think you know, and you may have actually just coded everywhere across your system a set of rules that actually you later want to change yourself, and you created a huge problem around doing that. You made your source code very, very fragile. So Ken said, so about 2014, there was a whole debate kicked off by DHH. So I spoke about 2013. So I think that this whole, I know DHH watched my talk, and this whole movement was effectively a group of people at this point, about 10 years into testing, noting that TDD had gone off the rails. So about 2014, there's an interview, you can find out the YouTube link there, between Kent, Martin Fowler and DHH talking about the practice of testing. And one of the things that Kent drew out even then was that I don't go very far down the mock path. Your test is completely coupled to the implementation, not the interface. And the idea is what we're trying to do with testing is drive an interface. That's a point we'll come back to later, not drive the implementation details. If you find your test is specifying the implementation details, you have gone wrong. Okay. So at this point, somebody normally pops out and says, but hang on a minute, that goal of unit testing, that I get defect isolation, that's what I want. If you've essentially said to me and that I no longer have to replace my dependent upon components with mocks, how will I isolate the failure to just one test? And the answer is that isn't how TDD works. In classical testing, failure of a unit test implicates one unit. In TDD, failure of a program test implicates the most recent edit that you made. The change you made caused that break. And you either look at it, understand it, and fix it, or you revert the change you've made and try something else. Defect localization does not work in the same way in TDD, right? You have implication that says, the most recent edit, the thing I just changed because I'm practicing TDD, must have been what caused that problem. We can kind of summarize this problem unit testing with this slide. So effectively, this comes basically from the C2 wiki, which is a very useful resource for if you want to investigate some of the history of agile practices. Test-driven development produces developer tests. Sometimes people also call that programmer tests. Failure implicates developer's most recent edit. You don't need to use mocks. And you tend to avoid debugging by reverting the last edit and trying again. That kind of key problem, developers write unit tests. If you can get it into your head that that is wrong, when everything based on that idea is wrong, that's the key to understanding how to get TDD right. Now there is this notion of isolation within TDD. And the key idea here is that what we call a test fixture, that's your test code, should run either independently or alongside many other tests potentially running concurrently. So one test should not interfere with the running of another test. And that really usually refers to what we call the shared fixture problem. And that's the idea that if I have some shared resource that all these tests are acting upon, then one test could affect the other. So if I have a test that keeps adding rows to a data store and a test that counts the rows in the data store, obviously the test that counts the rows in the data store will be impacted by the one that's adding rows to the data store. If the one that's adding rows to the data just leaves them lying behind at the time, or this one tries to run in parallel, and the kind of transactional element here, right? And so a result of that, there is some value in trying to eliminate shared resources where they will cause this problem for you. And that is where you do tend to get into this idea of saying, maybe I will use in my tests an in-memory database. Or maybe I'll make sure that I use transactions and revert them in a way that effectively enables my testing. Or maybe I'll use multiple copies of that file so that essentially each one gets its own copy at the beginning of the test, and then any changes it makes effectively can be discarded. Whatever you do, you want to basically isolate a test from each other. And so there is a unit in unit testing. It is really about the test itself. The test is isolated from other tests. This is a principle called test isolation, right? But don't confuse that with the system under test being isolated. And that is probably the source originally of some of the confusion that happens. Tests also need to be fast, and you quite often find that the need to isolate and the need to test fast and not do slow IO to database tends to result in you replacing a few things at runtime. You don't even need to use mocks to do that, right? It's quite simple to essentially just replace something with an in-memory data store nowadays. And sometimes what you can get, if you get really sophisticated, is you can say, well, if those things are swappable, I could run a version of my tests, use a concrete resource, and that I would actually use in production, a real database, for example, and I could use a version of my tests that would essentially run against a in-memory version, which is not the production system for speed. So developers get fast feedback, but I can always run one that runs against the actual database. And the reason for that is that behavior differs, right? If I don't ever run my tests against that real database, some of my behavior might differ. And actually the fact that I get concurrency issues may well tell me something I need to understand. Right? So it's worth thinking about whether or not you want to use a real resource, but you need to understand this problem of isolation and speed. All right. And fragile tests at the end. So sometimes essentially you will get tests that become very fragile if they depend upon resources that essentially have startup issues or timing issues. If you're trying to do a test using a message queue, really sending to one and reading off it again, you're going to get all sorts of timing issues, particularly running in Docker containers, and those tests can be very fragile. If you start writing code that says sleep for 10 seconds, etc., while you wait for something to happen, be aware it's a fragile test, and it's not necessarily a great TDD resource. Okay, let's look at our second fallacy. Our second fallacy is this idea that customers write acceptance tests. So this one sprang up a lot for me when I used to get people to write tests in technology called Fitness actually, which is basically the wiki port of Fit. And we would have a whole DSL expressed in Fitness, where effectively we took words from the kind of natural English-like expression, we turn them into a DSL. We would then parse that DSL, and we'd use that to drive our test framework. And the goal, which was quite noble, was this idea that the customers could become involved in the testing. So the idea was that the customer models and possibly even writes these tests. And so our on-site customer would be reviewing these things, reading through them and saying, yes, you've entirely expressed the correct behavior here. Congratulations, or hey, let me have the keyboard, let me write a test for you in this DSL, which I implicitly understand. And the problem a little bit with this model is in 99% of cases I've seen it work, it's failed. Now, I will admit that there are some people out there that have got this working, right? But I've never managed to entirely get it working. And as well as the whole problem of customers sitting them down, making them actually write the test, which they quite often don't have time for, getting them to do so in a constrained way. So Fit has a table, things like Cucumber or Fitness using explicit DSL, which drives things. Getting them to write in that constrained way is often not how they think. They're not programmers. And so they find it very awkward. I've actually had to sit a QA when I was trying this and the customer in a room and almost literally lock the door and pass food under in order to try and persuade the customer to engage with doing this. Some folks I know do make it work, right? But it's incredibly hard. You also have all the effort that developers need to do to write essentially the parsing of these elements, this DSL supposedly, and turn it into something that drives code. It's often fragile. It's completely non-amenable to refactoring. So because you struggle to refactor, because if you want to change how something works, to do with new insights, or if you're incrementally working, you get new behaviors or additions to those behaviors, it can be very hard to go back and rewrite these tests written in natural language or fit tables to now reflect the new reality. So a lot of the time you break tests because I'm introducing a piece of functionality over here that isn't quite how it used to work. A whole lot of tests go red. The other problem is that when you write these tests, the idea is you write them at the beginning of the iteration and over the course of the iteration they will go green, resulting in you seeing I have completed all my goals the iteration. But that means that they tend to stay red. So the combination of broken tests and tests being red at the beginning means no one trusts them. They spend most of their life red during the iteration. And at the end of the iteration, it's quite often someone's job to say, okay, well, we've got all the stories in, they pass all the unit tests, half the acceptance test, these acceptance are now failing. You better spend the next few days making the acceptance test pass. And that's always a smell, right? So if the idea is that your job is now to figure out how to make the acceptance test pass, rather than why don't the acceptance test just pass? Now we've implemented all the functionality they described. That's generally a smell that something is highly problematic. In fact, James Shaw, who's one of the creators of Fit, now kind of speaks against the whole idea. And he said, customers don't participate and they create a significant maintenance burden. And that's certainly my experience as well, that overall trying to drive through these acceptance test tools, Fitness, Cucumber, is generally a lost cause. It doesn't work well as an approach because no one really engages with this promise that the customer themselves can write the test, or that customers will sit down and review these tests, or that the team will actively maintain these tests and keep them green without force and effort. And in any practice where you find a team are really resistant, one of the questions you should ask yourselves always is, are the team resistant because they're just bloody minded, or are they resistant because they can't see the actual value that they're getting from doing the work? And that applies a little bit to TDD under a mock world. That often leads to pain because you're trying to put some implementation beforehand. People complain, don't want to do TDD because of that. And this is another place where TDD really creates a problem. And the alternative that James kind of suggests nowadays is says, look, the value you're getting out of any of this is the conversation with the customer. So typically in a proper agile implementation, the user story is a promise for a conversation. And that conversation tends to happen in a phase we call elaboration. We sit down with the customer, we understand the detail of their requirement, and we do some upfront thinking about how we as a team might build a solution to that, which we are then sharing collaboratively so the whole team gets an idea of that. Right? And James's point is that the customers at this point just illustrate examples. The customers can sit down and say, well, in response to a question, yes, we do that, and when that happens, we expect this to happen. You write those down at the time. You may choose to write those down in a given when then format. And you may choose to have QAs as part of that conversation, if you have them in your team, driving that question of, well, what are the acceptance criteria? How will we know when we're done? But you can record those in something as simple as a markdown file and use those to drive your TDD. You can use those to drive X-unit tests. You can simply say, hey, here is the requirement. And essentially, that's what's going to be able to inform my X-unit tests. Don't load up one of these essentially acceptance testing frameworks like Cucumber or Fitness, because you're buying something that won't give you the value back. An important aspect of this is, if I want my TDD to have a similar value, one of the things I need to do is make sure that my TDD creates tests that can be read. And we'll talk a little bit about that in the next fallacy. But one of the reasons that ATTD creeps into organizations is because people begin to say, well, look, I can't actually understand what the system is doing from these unit tests that I've written, right? And part of the problem is you wrote unit tests. You wrote these tests that are horribly mangled with mocks that I look at and it's got, 40 lines of setup, or effectively, if there aren't 40 lines of setup, it's because you've put all of that into some common base class that everything is now calling, and all of these classes all now refer to a base class that has 100 lines of setup code. And I'm looking at thinking, well, I can't understand what's happening in your test. It's not simple or easy to read, right? And so then people go, well, we'll have an ATTD test. That will tell us what's going on, right? The TDD was supposed to tell you what was going on. That's where you should have written something that was easy to understand. And ATTD is powerless to us because it kind of says, the problem is not that I did TDD wrong. The problem is I just need to add this other practice now, ATDD, to fix the problems in my TDD, right? The TDD essentially works. You don't need to add ATDD on top of it as a way of fixing it. So really try and move away from this notion of acceptance test-driven development. It's not going to help you, and wean yourself off tools like Cucumber, right? They really aren't that valuable. I know also that Cucumber recently has said, hey, writing all these given when thens and automating the DSLs, that's pretty hard and fragile. Maybe what we'll do is we'll write tables instead. That'll be much easier. And we're going backwards to fit, right? We spent 10 years on that solution. We understand its problems. Let's not reinvent that particular area of problem. All right. So this leads us naturally into this idea that when do we write a test? And in TDD, a lot of people have got themselves in the habit saying, well, what I want to do is write a new method on a class, so I need to write some tests around that. That isn't how we trigger TDD. And the problem with that is based on, I think it derives from these two earlier problems. This idea that the requirement is specified by an acceptance test. So all I'm writing is some lower level fragment that implements part of what's defined by my upper level acceptance test. I write my outer shell kind of acceptance test, and it says, well, I need to call this other thing internally that will actually then provide my answer. Oh, and here the concrete implementation of that, which I'm now going to write in this test, which is going to basically, when it's all plugged together, meet the ATDD test. And that's kind of wrong, right? In TDD, I'm trying to drive the thing that actually passes the requirement. And so the trigger essentially for writing TDD is I have a requirement. I have an acceptance criteria for a story. I have a given when then that says, given I have this, when that happens, then do this. That's what drives TDD, right? TDD is driven by the need to implement a requirement. So one of the examples Ken Beck has in his book is we need to be able to add amounts in two different currencies and convert the result given a set of exchange rates. That is something that a test in TDD is trying to give you the result to do. Nothing here says I'm trying to test the add method on my currency class, right? That is not the requirement that you are trying to pursue. There could be one class that implements this requirement. There could be a number of classes that implement a given requirement for you in TDD. You are not testing a single class at any point. You are testing a requirement. I can rewrite this as given when then. If I wanted to, right, I could say, given that I have amounts in two different currencies, when I add those two amounts together, then I get a new amount essentially in the first currency, right? That is how you drive TDD. It's not how you drive ATDD, which then essentially leads to some fragment in TDD. It's how you drive TDD, and always has been. What you do is you write the next test is the most obvious step to implement a use case or user story. So in an agile world, an XP where this comes from, you're dealing with user stories, a promise for conversation. They're very similar to use cases, and in fact, Coburn wrote a book called Agile Use Cases. It's just that we defer the point at which we actually figure out where that detail comes from. And that's why effectively one of the problems actually like XP speak about is this idea of technical stories, right? Because the stories are things driven by a customer and are a requirement that has acceptance criteria. That's what I'm implementing. And TDD just says, given I have this requirement that says, hey, I want to add to amounts in different currencies and convert them to exchange rates, what's the most obvious first step I could take towards fulfilling that requirement? That's my first test. When that's passing, what's the next thing I need to understand in order to get that together? So it may just be that your first test here says something like, I'm going to basically create an amount in a currency, and I'm going to test essentially that I can see that I've got the amount in that currency in that class. Right before you even get to adding it, you may have had the first test. It says, test that I have some test that I can get the currency and amount of money. And you just keep working your way step by step through all of the things that you need to solve in order to fix that problem. And that's how we do TDD. It's not how we do a TDD, it's how we do TDD. Dan North, very early on, I mean, I don't know the exact data when Dan said this, it may even have been like 2004, 2005. He pointed out this observation that test was a confusing word. We've seen essentially the results of that, to be honest, with the whole fact that unit testing crept in as an idea to our practice. And he said, I tend to think about it as behaviors. What I'm testing is a given behavior of the system. And he said that it became so insightful to him that with customers, he stopped suggesting they do TDD and started suggesting they do behavior-driven development, or BDD. Now, BDD now is a whole agile practice that has gone off in its own direction, has been infected by things like Cucumber, etc. And so I'm not necessarily advocating you look at BDD as a better alternative to TDD. What's important, though, I think, is Dan's original observation that what we are actually doing is defining the behaviors of our systems through this practice, and we're figuring out how to implement them. Okay, just check on my timings. The fourth most important fallacy, I think, is probably this idea that it doesn't matter whether you test first or test last. And I hear this a lot from people, nowadays saying, oh, as long as we have tests, it doesn't matter whether we wrote them last, whether we wrote them first, does it really, I don't really like doing TDD. Often people don't like doing TDD because of the first three things we've seen. That's why they've been put off TDD over time, right? But this notion comes out that test last is fine, we've got tests, what does it matter? All that matters is we have tests, right? That'd be fine if what TDD was a testing practice, and that's not really what it is. TDD drives a couple of things by the notion of putting the tests first that you don't get from test last. The first thing is that it controls our design. And what that means is that when I write the test, I'm thinking about the design of the system under test. So essentially, I am designing an API, be that an API, be that methods on a class, be that anything else. I'm designing an API, and I'm thinking about it from the point of view of the client. What would be easy for me to exercise in order to meet this requirement? What would I expect this interface to look like? Okay. And so TDD is essentially this idea of API first. Just in the small, it says the first thing I really want to do is think about the contract that I'm expressing to people. And we have this notion that tests should be easy to read, tests should express effectively the requirements. And if we drive in that with that motion, we will essentially get an interface that begins to express the requirements and the ideas. So our software will begin to look like the use cases that we want to express in the system. So without that model, if you test last, you're not getting TDD guiding your presentation of that interface. You have to go away and think of it separately. And maybe you think, well, I'm just thinking about it on a whiteboard, etc. You can do that and then use it to drive your tests. There's nothing that says you can't think about how that API looks like before you sit down and have a discussion on a whiteboard, then sit down and write the test and form that decision. What we're doing is saying is you want to do some thinking about the design of your code. And I see people raising this the whole time as saying, oh, well, the trouble with TDD is it's breaking the design of code. You think about designing instead, right? Nothing in TDD says you can't think about designing. In fact, it's almost the opposite. It says you should think about the design because the test is going to say, how do I drive this requirement? What should the software look like that gives me that? The other point we call scope control. because I am driving by requirements, because I say, what is the requirement that I want here? What is the acceptance criteria? I want to basically add two amounts in different currencies and see the result expressed in one of the currencies, right? Then essentially I have scope control. I'm not going to introduce behaviors or code as a result that aren't part of the requirement. All code we write generates bugs. Speculative code is the worst kind of code because it risks introducing bugs, but it also creates the problem of you saying, I'm going to spend time and money now on a requirement that wasn't given to me, that I'm guessing at, to implement it in some belief that later down the line when the requirement really emerges, it will look as though, hey, look, we've already built that for you, aren't we great? But you're not, because you spent the money already, right? I still spent the time building it, but I spent it here when the requirement was uncertain. And more than likely, when I get down here, I'm going to go, yeah, we had a guess at that. Doesn't seem quite right. We're going to have to do some rework. So now I'm adding this cost to this cost, and it's costing me far more to implement it than it would have done if I'd actually just waited and implemented when I had the requirement. And TDD forces that scope control on you. I don't write code that isn't necessary to solve the problem that I have, driven by the requirements that I've been given. We are, according to Kent, telling ourselves a story about how the operation will look from outside, right? This idea effectively of API first we just talked about. And one of the nice cross checks is if you sit there and you say, Ian told me I had to write a test based upon the acceptance criteria, and I don't really know what that is, then stop. Stop and go away and figure out what the requirement is. Go and ask somebody and say, hey, what's the requirement I'm supposed to be writing this against? Because if you don't know the requirement, you shouldn't be writing any code because you're just going to be wasting money, right? But TDD is surfacing that problem to you. What is the requirement? I need to understand the requirement in order to write the test. The other thing that Ken raises as well about test-driven development is it can be enormously helpful for people who want to ask the question, how do I start writing software to solve a complex problem, right? Particularly, the way we quite often learn programming languages, we learn how to do individual things like write to the file system, create variables, etc. But how do I actually create complex software? We often talk about this idea of decomposition, break it down to small parts, and then implement each of those small parts, and then the whole thing builds up. And TDD really drives that way. TDD, if done properly, says, here's this big requirement. Okay, what's the first thing, the smallest thing I can do to move towards implementing that overall requirement? Great, that's now pushed me one step down the line. And Ken, or Martin Fowler talks about this actually, but one of the things that I tend to suffer from ADHD a bit, and one of my things is that the test cycle is quite neat for me. I tend to do things about Pomodoro technique, etc. It says to me, focus for like 20 minutes on implementing this test, and then break. Focus on 20 minutes on implementing the next thing, and then break. So this wall of there's just so much, where do I start, can be controlled a little bit because you say, I just need to do the next most important thing to get towards the end. Another thing Kent recommends is an idea called a test list, which is very similar to the idea, of managing code ADHD, where you write stuff down, or Pomodoro technique, you write stuff down in a list as it occurs to you, or any one of these, just write it in a list, or anyone write this, so you can keep focused on the work at hand. And that's another useful idea. It's a list of tests that I need to write in order to implement this requirement, and you just can pick out the next one that you think is most important to get there. So you lose these things if you don't do test-driven development. You lose design, you lose scope control, and you lose a way of working that helps you conquer a problem by breaking something down. And there is absolutely no conflict between the idea of doing a little bit of design up front and doing TDD. None at all. Okay, this notion that you want 100% test coverage of your code. This is a sense a significant fallacy, partially because, as we'll look a little bit later when we look at where we test, there are some parts of our system we just don't really cover with TDD. TDD is best focused really at your domain code, at your use cases, because that's what you're driving, and it's not best focused at your kind of I/O code, your adapter layers, the databases, to web controllers, and the like. So focusing on, well, we have to get this under test, leads you to build some strange kind of code around automating and driving third-party frameworks that's entirely unnecessary, right? And even essentially code that you're working on yourself, in not all cases does TDD really help you. Okay? So we mentioned before we should basically write down speculative code and refactoring when we create a new test. Well, it's worth pointing out this. So we test first, effectively, all the code we're writing is in response essentially to a test, right? So in theory, it'll be 100% covered. And we don't want to introduce new paths because when we refactor, what we're all doing is making a safe set of changes that shouldn't result in, say, for example, an additional branching path from an extra if statement being introduced, right? So if when you commonly get a problem, you refactor something and you think, oh, I should have had a check there to see if that value is 0, I'll write an if 0 check. And you don't write a test that corresponds to driving that change. The value of code coverage tools is they tell you at that point, hey, hang on a minute, it's just a path you've introduced in that refactoring, and the path you've introduced in that refactoring has dropped your test coverage because actually you've introduced a path that you haven't got under test. There's a prompt to get you under test. So code coverage tools are useful in that context, and in the context of saying, hey, you did have X%, it's now dropped to Y% in that refactoring. You've, in that refactoring, done something which has potentially introduced a path that wasn't under test. You need to check for that, right? So code coverage tools are useful as an aid to your refactoring steps. But when you see people will put, code coverage as a requirement, we must have 100% code coverage before you can go to production. It's a nonsense, right? What does that actually mean? Why was that line of code important to cover before we went to production? If you can't tell me that, what's the point in the metric? Because not all of our code should be driven by TDD, right? But you get some things that effectively are worth leaving out, where you say you won't get 100% coverage. TDD has never worked well with visual output. Trying to drive the user interface requirement through tests doesn't make a lot of sense. Usually what happens is you've got some UX designer who's essentially designed how the output's supposed to look, and you're trying to produce something that matches that requirement. There's in no way that you're exploring that requirement at all. Essentially, as part of your activity, you're not in danger of writing speculative code. You're writing the code to implement that particular interface. And the value of getting under test is quite often broken by the fragility of the tests that you write. So generally, it's a bad experience to try and use TDD to drive visual output. There's no point in writing TDD if what you're doing is spiking something or prototyping something to discover how it works. It just adds overhead. You're better off using something like a REPL or a small test harness, just even a console app, which will let you change stuff and explore how it works. Exploration code generally doesn't work particularly well for TDD because it's just adding overhead and you're going to throw it away. Some folks get so ingrained into TDD, it does help them, right? And so no one's saying, you know what, actually if that helps you, fine. But be aware that's just being thrown away with everything else that you used. I would say don't drive integration, right, by tests. If you are essentially saying, in order to call this third-party thing, I need to basically pass parameters in this correct way, and it needs to have these values, TDD is not the way to do that. Look at the documentation and write the thing correctly, test it by running it effectively manually against the piece and see how it works. But there's no real value in trying to drive that through TDD. It's an exercise in following the documentation. And don't drive third-party code, right? Don't test code that comes from a framework that comes from somebody else that you're using. If you're using Brighter, which I write, don't try and test that Brighter works. If you're using Espionat MVC in .NET land, don't try and test essentially that your Espionat MVC controllers work, right? Don't do that. If the .NET team didn't get it right, that's their problem. You are not there to test controllers. Okay. TDD is sufficient. So this one comes up because one of the problems that we're seeing outlined there is this idea that TDD is a practice that effectively means our system is under test, and that by doing TDD, I will have a completely tested system. And that isn't what TDD is for, right? TDD is much more for driving your implementation of the code to meet the acceptance criteria of the business problem that you're trying to solve. It is not about saying that this solution is end-to-end verifiable and that when I do a CI process, my TDD created tests will prove to me that this system works completely and has no problems in it, right? You need to do other forms of testing to get you there. We are not saying that you cannot automate testing your UI. We're not saying you can't automate testing of your HTTP API. We're not saying you shouldn't use pact-based testing to do consumer-driven contracts against your API so that you can check for changes. You're not saying we shouldn't look at the messages that we produce out of our system by consumption by others and check that basically they conform to a given schema and that they are correct. We're not saying that I shouldn't check that I haven't set up my database schema correctly and that I'm not making breaking changes. All of those things are valuable parts of testing, but they're not parts of TDD. And we don't need to drive them by TDD. There are lots of ways of doing automated testing, but they're not necessarily part of TDD. Keep TDD focused on what we're doing, which is driving the requirements. Right, I'm just run through those fallacies and then we'll get into something, a couple of other little tiny points. I'm aware I'm overrunning slightly. I've not done this talk before, so I need to look at my timings. Developers write unit tests, right? This is this idea effectively that we don't care about unit tests. We care about tests, particularly developer or programmer tests. Notions of isolation, mocking dependencies, etc. We're not here for those. At least that fragile tests, overspecified software. We don't care about the structure, we care about the behavior, right? Customers write acceptance tests. Generally, that practice is going to lead to fragile tests, constant red acceptance tests, usually has very little customer interaction and doesn't give you the benefit you want. Actually take those specifications that the customers give you and drive your TDD with it. And it's a symptom of your TDD being done at the wrong level, right? Trigger test is a new function. No, the trigger for a test is actually a new requirement that you want to implement by TDD. Doesn't matter if test first or test last. You don't get essentially design by test last. You don't get scope control by testing last. And you don't get a way of working that helps you break down a problem into small digestible pieces if you do test last. And you want 100% test coverage of your code. No, you use code coverage tools to prevent issues in refactoring where you accidentally introduce additional paths, but you use it as a tool as you go along rather than some arbitrary metric of how much your code is under test. And TDD is sufficient? No, it's not. TDD is one practice amongst many in the automated test suite. I want to think about basically the idea of the testing pyramid instead. All right, let's run quickly through some of these additional pieces. So Red-green-refactor is the classic workflow you use when you are doing TDD. You say basically, right, little test doesn't work, it doesn't even compile first, right? And what we've established is that what we're doing in that red test is we're taking the next smallest piece of the requirement we have from the customer and saying, how do I get one step closer to implementing that requirement? And I'm doing design. I am understanding what the system under test looks like from a design point of view. How should this API work? How can I clearly express by this test the behaviors that I'm driving? So to get to green, we say, now I have outlined the test, the requirement. What I want to do is implement something that gets it passing as simply as possible, okay? So speed is the essence here. What is the algorithm or solution to the problem I need to understand? And refactoring, then we actually make that good. We go into that piece of code we wrote during green and say, now we want to do proper internal design of that implementation detail. When we refactor, we are changing the structure of the code that we are looking at, but none of our tests should break. So you write the test, make it compile, want to see that it fails, make it run, and in theory, remove duplication. So remove duplication is effectively one of these goals in refactoring. I think there are a lot more things you can do to refactor, but early on in TDD, this idea of duplication being the key smell came up. I would say there are other smells you can look to. But this red step is key, this red to green step is key. And what I see is a lot of people kind of skipping this in their head. They're saying, oh, I don't want to write a red test really. I don't want to think about things. The red test is the design phase, right? Oh, when I get towards green, I kind of know how this all should be implemented. I don't want to just write a transaction script of the whole thing instead, right? But the problem then is you risk introducing whole sets of elements that really are unrelated to the actual scope that you are trying to implement. You just do as the minimum possible to get the scope built. And you can cut and paste code out of Stack Overflow, etc., straight into your implementation details, fine, right? We all work that way. And the actual admonition that Kate is giving you at this point, it says, do that. Go and do what we all know we really do, and go and actually use that to build your implementation. And then you do essentially refactoring. Okay. This idea of duplication or for foul or sanitizing code smells. And it's also the point to use patterns. So this even emerges basically in Kent's book originally, this idea that if you understand software patterns, when do I apply them? This is because problem that people became pattern happy, they saw patterns everywhere. And the idea is that really the place that patterns as a solution emerge is in this refactoring step. You say, what I'm doing here looks like basically this particular pattern problem in context that I now understand from having implemented the green phase. So actually, this is the right solution here would be to use this given pattern to restructure my code. Right? And you can see here, this is from Ken Beck's original book, identifying where patterns might be used in test authorship, but also where patterns can be used typically inside your implementation. It's a good target to use your patterns. One of the key things to understand of this is when I'm doing that work, I don't write new tests. I can restructure my implementation code. I don't write new tests. Even if what I'm doing is introducing new classes, new methods, they are implementation details of the code that I currently have under test. I've written the interface to this module, whatever that concept means, right? I've written the interface in the test. That's what I'm driving. If I decide, when I look through that script that basically I wrote in the green phase, that actually it'd be great to have 3 cooperating classes implement this, and I break those out. They don't need new tests. You don't write tests against those classes. That's a structural decision that you made to implement that requirement, underline that particular external interface with 3 classes. Someone else might come along in 3 months' time and say, that was madness, we only need 2. Right? These 2 things are actually behaving exactly the same way. Let's combine them together into 1 class. No test should break as a result of that change. Remember, one of the things in software we're trying to do is this notion of called implementation hiding. I'm trying to hide essentially detail behind an external interface. So when I'm testing, I'm building a requirement, I'm looking at something that's really a facade over some set of cooperating things. And it may be that 1 class is enough to build that, but it may be that 6 are required. And you don't require new tests. But that's why you need a code coverage tool to make sure that as you make those kind of refactoring steps, that I'm not essentially at that point introducing new paths. Okay. And people get challenged by that idea. They believe that every single class has to effectively be under test. And that leads to the problem of people surfacing all of their classes as public, or in .NET land, they're writing internals visible to in order to get things under test. That's a huge problem, right? There are things that are just implementation details that could change. They're part of the structure of how you implemented that requirement. Don't touch them. All right, and that leads us to this idea, clean architecture. So I used to talk about hexagonal or ports and depth architecture. At this point, clean architecture is a kind of modern synthesis of the principles of a number of architectures, BCE, onion architecture, and expressed in a new form by Bob Martin. That's what one looks like. So everything depends inwards. I do a separate talk called Clean Architecture. You can see it's linked on my there's a YouTube effectively account you can get to via my LinkedIn profile, which basically has a playlist of all of these. But in the center of the entities, so entities are effectively things that have both state and behavior. The behavior depends upon that state. That's the heart of our business logic. Around that, we have typically what we call a use case layer. And that says this is basically the thing that implements a requirement that these entities support. Use cases being a user requirement that you've generated from an actual user, and those use cases generally take 1 or more classes to actually implement. Outside of that is where we plug into frameworks, typically provided by a vendor or third party, and we're writing something like our ASP.NET MVC web controller, etc., like that. And beyond that are the actual outer periphery of things like where an HTTP request generally comes in, where a database lives. And the important notion of these kind of architectures, it depends inwards. Everything outside can depend on something inwards, but things inwards can't depend on things outside that, right? Okay, so I don't want to get into details of exactly how we build clean architectures at this point, but what I wanted to get into a little bit is this idea, this notion effectively that I have a delivery mechanism, say for example HTTP, it drives effectively a boundary layer which would be something like effectively an exponent MVC controller in .NET land. We have a request model, things that come in on the parameters to that call. We have a response model, we put it back out basically to the caller as a response. And we work through an interactor. So we don't actually do all of our business logic directly in that controller class. We call this interactor, sometimes think about it as a service layer, right? And that service layer is where the use case is implemented, and it drives how our entities and so entity gateway, which is registered database, works in order to essentially implement the requirement. Now, we said earlier that the thing we were trying to do with tests essentially is drive use cases. We're trying to drive requirements for our tests. And the reality is that our unit tests are written against this use case layer. You don't necessarily tend to write them against the entity layer, you write them against the use case layer. We're saying, well, what is the API that I need to call from my controllers, from my presenters, my gateways? What am I actually trying to drive, right? And that's where you write your tests. And your test is just another adapter in this model. There's another interface adapter alongside your SPN web API controller, or whatever your particular, or your UI framework, your Razor pages, whatever's driving this particular piece of code, your tests are just an equivalent. And you are driving that use case layer. And so here you can see this idea that my tests are just another one of these interface adapters. And I have some kind of request model. It's, what am I passing across to the interactor that I new up inside my test? What do I expect to receive back from the interactor? And what do I actually test for my, how does this behave correctly against? And so that test operates with the interactor, not directly with the entities. And I may have some notion of a database, and a database that I'm getting stuff from, I'm doing some substitution to make my tests work fast. That is the kind of model you use when you're driving your tests. And effectively, one model that you can use here is to use something like Brighter, where essentially you have a request handler, you have a concretized implementation of that, and you drive that request handler as part of doing your testing. That is where the use case lives. All right, we don't write test against the adapter. Don't get your MVC controllers under test. Two real reasons. One is, first of all, those things change a lot, right? Once upon a time, we used web forms, then we used MVC or Open Raster, effectively, etc. Now we might use Web API. Really, you want to be able to throw those away. And also, the whole point of getting those things under test is why, right? They're just one adapter amongst many that you could be using to drive your code, which includes your tests. And that's this whole point about you're not seeking 100% test coverage. Okay, that's just another adapter. You can write little integration tests to make sure those things are hooked up correctly. For example, checking that all of your properties persist via an ORM correctly to the database. But generally, you can rely a lot on system testing, right? Old school automated system testing that tests essentially your system. Right, some old school automated test against your API, by the happy path, check everything is hooked up together. But the bulk of your effort is really around testing those use cases, not these other areas. All right, let's back to wrap. So it's also worth mentioning this. Came up with a set of principles a couple of years ago, which effectively I think are worth mentioning around how to write TDD tests correctly. They respond to behavior changes. In other words, essentially different changes in requirements, but not to structure changes, right? You should better change the implementation details in your tests where effectively you remain green. They should be fast. Right, one of the major reasons why you may want to use a mock is to speed tests up and make them faster, or because you want to avoid issues of shared fixture. Shouldn't be fragile, in other words, basically avoid these kind of shared fixture problems. Any tests that essentially regularly break because they're fragile, consider how you could rewrite them or just abandon them as part of your TDD suite. You may need to have an automation test that looks at those, but be aware as part of your TDD practice, which really needs a response in seconds, that you don't want those tests to be involved. Should be cheap to write, right? If you spend hours writing a test because of the way you're building all your mocks, etc., that's a problem. You should actually be able to write them quite fast. And the fact you should be writing less tests than you may have done previously, because you're testing at the use case boundary. And so even if that results in 8 classes to implement that one requirement, you're not testing every single one of those. So the amount of tests you write should be less. They should be easy to read. The test should be expressing a requirement that is readable by a customer almost, right? make your tests easy, right? If your tests just look like a piece of technical garbage that no one can understand, they're not going to be much help to you in 6 months' time when you come back and look at them. They should be easy to change, which kind of relates to that. This idea that essentially someone will be able to come and read your test and figure out how they need to change it because the behavior requirement has changed. All right, I'm going to switch cameras and go and sit down, and then you can ask me some questions if you've got enough time. Thank you. All right. Okay, did everyone that work okay?
Yep, you're back, Ian.
Yay.
Feel free to unmute, guys. If we've got any questions, just pop them in the chat box.
That was great, thanks, Ian.
Stunned sort of silence.
I have a question.
Go for it.
So the requirement, the behavior driving, one behavior can be really big, and if we focus on this big behavior, on what degree we should break it down, to the implementation. If this behavior is, say, very big, if you just write one single test some input, and then test the output, then we sometimes could be struggling to get a green light because the implementation it is so big.
Sure. So, I mean, the goal is to write the next smallest step you could get towards that requirement. There's a notion we call, driving in gears, right? And that says from TDD. And it's a bit of a strange analogy, but over time I've come to understand that what Kent means is that most of the time you want to drive down the road in 4th or 5th gear, right? And that means essentially that you are just taking this large requirement and breaking it down in a series of steps to give you individual behaviors. Sometimes it's too confusing, and what you want to do is drop to a lower gear, and then you may want to actually peer at part of this and say it's too complicated to understand as one big requirement. I need to understand what the parts of this requirement are, then I can address those instead. So you just need to break down the original requirement a little bit more. But a lot of that's to do with your requirements analysis, right? You're saying this requirement is too big, and often it's a smell that you are trying to express too big a concept in the API. It's a sense of saying, I once worked with a system, I won't explain why or where because I don't want to name the guilty, that was written in Visual Basic in COM, that essentially it had one method on it, which eventually you might as well have been called do everything. And you had about 8 arrays, basically, you passed with it with various parameters set, and then it would perform one of the many operations that this system gave and spit the results back. And it was almost impossible to use because this is the craziest API ever, right? This idea that I've just got one method that says, I am the system, call me, and I will do stuff. So I think if you're finding that you've got this big API that says, hey, you give it inputs, it spits outputs, and that's too huge a requirement, then that's too huge an API, right? You need to actually narrow your focus down on what that API should be doing to smaller elements. You can drive some that way, but I would say the problem is in the specification, not in the technique.
Thank you. I think I understand that writing test is basically to break down until it's testable. But then sometimes, for example, for one API for accounting system, let's say, when you create a commercial invoice, you have many ledgers to update to the database. I mean, and sometimes the condition, the one API is in nature very complicated. People just add one single entry of invoice. Many things happens in the system to update the ledger, to update the balance of the counterparty and such things like that.
Sure.
You can't break it down. You just sample very, very simple action, which has loads of side effects.
So I'd look at what it is that you're trying to do. So first of all, what is the use case, right? Don't worry about a UI, don't worry about a report or anything like that. Say, when I make this change, what are the set of things that should occur? can I see those in some form of, how would I get the output for those changes, right? What would give me the output back? Is there some API, is a response back from this API going to be a DTO, which gives me the new invoice? Is that how it works? If I say add an entry, the API gives me back a new invoice. That seems like a sort of strange design to me, that I would say, I add a new entry, I get new invoice. Now, it would feel like there were other things going on in terms of the requirement. But if that was the case, sure, I could do that. I could essentially say, hey, I add something, I look at the set of outputs that come in response to the method, and I find the relevant entry that corresponds to, and I check it exists. But the first thing you might want to do is write a test that says, hey, I've got an invoice, it has a heading. Hey, I've got an invoice, it has a heading, the date. Hey, I've got an invoice that has, if I add a new transaction, it appears on the invoice, right? And you build it up item by item.
Yeah, thank you. I think, yeah, if it's not testable, it's not a good design. I agree with that.
Ian, I have a question which is very similar. So if you, for example, you have something that generates an invoice, let's say, for example, that same thing also needs to do something else, update some record in database. My worry with that sort of thing is you end up with very long and complicated tests. So, for example, where you're testing the invoice stuff, you may need to do setup code for that other behavior as well. So,
Sure.
if you're not mocking things, is there something you do to avoid the test getting bigger and bigger?
I tend to work with different types of patterns to do that kind of thing. So things like the test data builder pattern, which tends to say that what you're focused on is evident data for the change. So you create a builder that says, I will generate that code for you, and I have some overrides. And I override methods on that to set data which effectively will be impacted by the test, and use that to create whatever my underlying representation is. I mean, I'd always say, you know, if you get to the point where literally you have, hey, I make input and get big output, I'd question whether or not that is a sensible API, right? But if you do end up with those situations, which are outliers, then I would say, sure, use something like a test data builder to construct the data that you need to insert in order to basically test that when you make a modification, that data is changed appropriately.
Okay, thank you.
But you can use in-memory databases, that's fine. I mean, you tend to get otherwise fall foul of the requirements around avoiding shared fixtures that can be used concurrently or not running fast enough. So you can use memory. A sweet spot is being able to use both, right? To be able to say, I can swap at runtime with whether I use in memory or the real thing, which allows you to run your test suite against essentially a concrete representation to look for the errors that occur when you actually talk to a real database. But it may not be fast enough to do that and give feedback as part of a TDD cycle where you should be able to see your green bar coming up in a few seconds.
Hey, and I've got another one that's sort of similarly related to this idea of complexity. It's we started off with this idea of trying to test only effectively the public sort of outside interface of our code when we started in TDD. And what we seem to always find was that you start off and you write something and you do your null tests and your zero tests and you test that kind of core functionality, which is quite small, and you end up with, say, 10 tests. And then you introduce another level of functionality to that problem. And now you need to test, so say you introduce another 4 permutations of where you're adding more functionality into this API. And now it really feels like you need to test your original 10 tests across those 4 permutations, which ends up feeling like you end up with a huge amount of sort of near duplication in your tests. So say you were doing a kind of exchange rate calculation at the beginning and you're passing in an amount and a currency to your API. And then later your exchange rate is changing across the time, across the day. So you're then adding in the time. So now you've got 4 tests around the time, 10 tests around the original conversion, and you need to test that these numbers still calculate correctly across the different times of the day. Is there a way around that kind of problem? Because that's why we ended up breaking those things down into smaller pieces in order to I
don't think you want to way around that problem, right? The idea is that each one of those forms part of your requirement. and that when you under test, you'll discover that essentially all those pieces work together correctly. And if you start breaking it up, now I have created a problem for myself that I have to determine do these individual pieces work together, which means I'm adding a whole other level of testing around integration testing. And the reason I think you think that you want to do that is because you tend to believe this model of unit testing that says each test is just test only one thing. It's not, it's testing a given requirement, right? And those requirements have to continue to work in the presence of other requirements. So your problem is that if you try and focus on the idea that this test just tests this aspect in isolation from others, that's when it breaks for you. You will get your test will be too complicated and they do too much about structure. What you want to do is say, it's fine that I get tests that essentially cover the same thing. The criteria is that when a test breaks, the most recent edit changed something that was essentially led to that breakage. And that's the most recent edit I focus on and look for, do I need to revert? But breaking up into smaller pieces, I understand that your test code is going to exercise the same code in many of those tests. And that's actually a good thing. That's a good thing because it's telling you effectively that at each step that you make, that the new code that you add hasn't broken existing code.
Okay, thank you.
On that note, is there anything actually seriously wrong with a bit of duplication in your test code? I know you wouldn't want to write it in the production code, but the way you write test code is not the same as you would write production code necessarily. So a little bit of duplication there keeps each test independent of each other. So it's not actually necessarily a very bad practice. But if you're finding that you're writing a lot of copy paste kind of setup code particularly, that's an area where those builders that Ian referred to will come in very handy, where you essentially get a builder to create a default object and then override the properties of that default object that are relevant to your test.
I think, yeah, I definitely accept that. I think it's the idea that you write a load of tests and you're saying, I don't know, £20 times the exchange rate equals $15. And then you introduce something else and you're writing kind of, that because you developed it, that you're re-exercising the same code, and it just feels wrong, I guess, because we're so used to, on the development side, trying to dry things out that it feels very alien to then be
wrong.
saying
in test code, it's absolutely fine because
sure.
you think as a test, a user would be doing the same things over and over again on a different day. Why shouldn't the tests?
Yeah, a very good point. Yeah.
With that, what happens if if that requirement changes and you have it in lots of places?
Again,
Can you repeat that? I didn't hear the question.
If you've got lots of duplication in your tests and then that requirement changes, then you've got to update lots of tests. Or are we saying that would be in a...
So the builders will lift out the problem for you such that you get one place to change it.
Okay. Yeah, the builders change the interface with the class that you're wanting to test. But if you're saying that the genuine requirement changes, then it might be that the test is now obsolete because it reflects something that the new requirement has replaced, and therefore the test can actually be deleted. It depends on what that change of requirements actually is, driving. Is it that test is now not applicable? Or is it that you need to change the interface of that of the class that you're developing? In which case, the builder is probably the easiest route to go down.
And some of the problems you can find with tests is that you get into a situation where you don't know, is a test broken because particularly with very granular tests, did this test start breaking because the requirement changed and actually the test is wrong? Or did it break because the implementation is incorrect and therefore that caused that failure? And so by focusing our tests on requirements, we should be able to see, and clearly expressing them, we should be able to see that when that test breaks, we're no longer meeting the requirement, and we need to confirm that that requirement still needs to basically be true or has changed because we've changed the way that, changed what our requirements are. But it's much clearer if you say, hey, there's a broken requirement rather than there's a broken fragment of the thing that makes the requirement that now doesn't seem to be producing the right result, and I don't really know why. And that's why you need to try and focus your tests on requirements.
Can I ask how people feel about, we're talking about a test here that has many, many permutations, and lots of testing tools have tooling around sort of data driving your test, either through inline data or reading from another source, etc. And in cases where you have lots of permutations, it's quite easy just to add another line of inline data or something to prove out that case. But of course, that doesn't necessarily mean that, you know, we've now got a test that matches the code that you've just changed, as you've been saying throughout. So how do we feel about that as a thing?
I think it depends. If what you're doing is saying, I'm adding a new requirement, then you write a new test, right? If what you're saying is, I'm modifying an existing requirement with some additional factors, then you can modify an existing test, which I think maybe what you're asking. You know, what you're always trying to do in TDD is take the next smallest step, right? So if it takes you a day to write a test, then you've gone wrong, right? The test is something you can write in 20, 25 minutes. If the test is so big because the API is too coarse, then you need to probably think about whether that's the right boundary level to set your API at.
I think, so the specific example was about adding another parameter, adding permutations to a pre-existing suite. So you'd need to test days against currency exchanges. And to me, those kind of things, we would just add another couple of lines to a set of test data with the expected output, and
sure.
We wouldn't duplicate the test perhaps, but we just
Yes, you're asking yourself the whole question that what your API looks like. If your API would essentially say, well, the best thing to do would be to add, if I think about how I design my API, the best thing to do is add some extra parameters to the API. You modify the existing tests, right? So the question is always, what am I designing? The tests essentially are the point where you do the design is in red. But you can think about the design, right? And then you say, well, the best way to handle that would be probably to add additional parameters to our existing API and modify the existing tests. You've got a new requirement.
In that case, when you're adding stuff to an API, you're breaking the contract, aren't you? So if you want to maintain backward compatibility, you need to create a new area and support both versions. That's what the existing test would actually prove to see if you've got any side effects from your changes.
All right. So anytime you change basically the public interface, you risk essentially that anyone that's consuming that API will also break. So it does tell you that you're making a more significant change if you essentially need to change the tests. Think of all the other things that are consuming it that also need to basically change in the same way. Right. Yeah, you're absolutely right. That you're indicating it's a breaking change.
Can I just ask Justin on his original question? Actually, are you talking about just adding a new, like on NUnit, you add a new test case, or XUnit has another attribute, doesn't it? Are you talking about adding another line to those like attribute inline data things to run through the same test as already been written?
Yeah, perhaps. I mean, rather than duplicating the test for different data, if it's the data that's the only thing that's changing here, and you can specify exactly what the inputs are and what the expected output is as data. Then you can run the same test repeatedly.
On that note, I would ask, is that actually a different test or just a different scenario?
I mean, it's a hard question to answer because it depends on the scenario, right? In some cases, so it's a different scenario if it's a different requirement from the user, right? If it says, hey, when I add two currencies, but one of them is on this list of currencies that I can't trade in, generate some kind of exception or whatever effectively, that's a very different requirement. Whereas if it's just add these additional list of currencies to the exchange table, that's potentially a modification of existing requirements. It depends whatever is the easiest way of you solving that problem such that it's readable in the future. And that's what you need to tend to think about is, if I was to review these tests in the future as a expression of the behaviors of my API, what would make most sense to me? If I spread that requirement over 4 tests because it just turned out that it came in iteratively, is it sensible to have 4 tests, or is it sensible to have that one requirement that was built up modified in those tests? And I'd ask myself whether that first version still made any sense? Am I always going to basically be using it in the more complicated version, in which case it's just a test? Or is the first version still available as an API? I've got some more complicated additional parameters to that API that I could use and add a different test. But everything is driven by the requirement and the design of the API that you are getting under test.
I think Rob had a question as well, isn't he? He's put his hand up on the participant
Yeah,
side.
sorry, I wasn't sure how we were gonna run the questions, so I thought I'd just do everything. So firstly, thank you for the talk, Ian. Nicely done. My question is really, I'm always trying to have sort of practices that can follow around and stand the test of time. And I think I find that with test suites, if you've got someone who's flying solo on it, or maybe if they're pairing, they end up in a situation where they've got code that they think is great. New developer comes along 2 months later, 6 months later, whatever. Because they don't quite understand it, that code is instantly legacy code. Goes through a complete rewrite, and we're kind of back to square one. So one of the things I try to do a lot is actually save the last requirement for someone else. Sort of take that over to them, say, check out my branch. How easy is it to add that last requirement as part of this wider epic or whatever? I was just curious, are there any other things or practices that you find that are good ways to stress test the design of the code, the language used, how things are expressed in any of your test suites?
I mean, it's a great question. I think that the discussion of how you define APIs is a really long one, right? And that actually Microsoft did a whole lot of work on this back in the 90s and talks about learning styles, etc., that kind of thing. Obviously, it's a problem. I think there are two problems I want to talk about. One is the design of the API, and the other is the implementation. I think that one of the things that mistakes actually a lot of teams make is they don't discuss during an elaboration phase what they think the design will look like, and they don't share that in a way that is essentially neutral and just says to everybody else, hey, we're thinking of designing an API that looks a bit like this. Anyone got any thoughts? So that effectively we all have some vague idea of the direction of how we think that API should look. So that by the time we get to testing, it's easy to write the test. There's this idea that the test should take about 20 minutes, right? And so if it takes me 4 hours to write the test because I've got no idea how the API should look, that's a smell that what I need to do is I've gathered the requirements for. I should stop writing code and go and talk to the rest of my team and say, what do we think this should look like? Or hey, maybe I should pass this around a little bit and see if people think that's a good idea about where we're going. And it's that aspect of TDD that I think is often misunderstood, that it forces you to do some upfront thinking and says, if you can't write the test because you don't understand what it is that you're trying to do, then stop writing code and go and understand what it is that you need to do. The second thing is about implementation varying, and I have no way of fixing that. Programmers are programmers, right? And the way that you implemented the code is idiocy, and the way that I'm going to implement the code is genius. And given a decent test suite which doesn't have understanding of the structure, then it ought to be possible for you to write the test, the entire implementation the way you wanted it. Keep my test passing and say, look, I've improved your code, it's now much better. I think people just need to talk better, and I don't think TDD will solve that problem. I think if you were going to make a check-in that said, hey, all this implementation is nonsense, I wouldn't have done it this way, that's a conversation to have another team member and say, dude, I thought we could do it like this, and try and pair on it. I think it's just manners and civility, because you may find why that person didn't go that route because they found out something else they already knew. ADRs and stuff can help, where you're essentially recording, why did I build it this way and not that way? The other thing, sometimes just to let go. I learned over time that getting frustrated because somebody rewrites my implementation because they think they know how to do it better may not be worth it. I try to learn to live with that a bit now and just say, okay, dude, let's figure out whether yours is better.
There's a couple of nice things you said there. I think the idea of a 10 or a 20-minute test is a good one. Like, if you can't crank out a new test within this time frame, then we're probably doing something wrong. I think you've also highlighted something else that I've found too often people don't have conversations. At some point, a talk about design becomes synonymous with big design up front, and I'm like, no, that's not the same. Thank you.
And big design up front, right? I think it's worth mentioning that here, right? Big design up front. I had the fortune to work at an insurance company at a point in time when they were split between doing waterfall methods and doing agile methods. And the waterfall-based team delivered on time, to budget, to exactly the requirements and the specification, right? And they were popping the champagne corks and everything else. The users wrote one piece of business with it, said the thing was completely unfit for purpose and threw it away. And the team said, we implemented the requirements that you gave us. And they said, well, who gave you the requirements? And they said, oh, it was Bob. We just pick a name out of the ether. And they said, well, Bob was an idiot. We fired him 6 months ago, right? And the problem is the validation of the code needs to be done by the users on a regular basis. And that's what's meant by the problem of big design up front, is between the point that you decide what the system looks like and the point that the user basically starts using it. If that's 2 years, chances are you're going to fail. What we mean by the problem with big design up front is that length of gap. If you sit around with your mates and essentially say, hey, we're going to spend Monday talking about the design that we're going to implement next week, that's not big design up front, because the time period between you making some guesses about what you want to do and getting feedback on that by writing the code and adjusting course is so small that it's not a problem. It's the length of time that we care about. It's basically, it should be called long and advanced design up front, as opposed to close in time design up front is really the problem.
You just coined 2 new terms there.
Dwight, I can see your virtual hand is up as well. Do you want to?
Thank you. Thanks, Ian, for a great talk, and IO for organising it. Ian, I'm really interested to know how all of this would apply, say, in safety critical systems. If we're a SpaceX or a Boeing, do you think 100% code coverage and method level testing has a place in those kinds of environments?
I can't say I've ever worked in those kind of environments, right? So I find that trickier to give you an opinion on. I would assume in lots of environments, TDD can help you do design and help you reduce speculative code, etc. I would refer you to the point saying TDD is useful but not sufficient, that you would have to supplement it with other ways of demonstrating that the code make your safety critical requirements. But I don't know enough about building safety critical systems apart from some vague module about Z that I did once when I was a student, but I would hesitate to give anyone real advice. I don't want anyone going up building safety critical systems saying Ian said, because I know nothing about building those requirements. Do you have any wisdom to impart?
No, I mean, it's been a real eye opener, this talk, because you having come to TDD after Kent wrote the book, I've fallen down the rabbit hole that many of us have fallen down and thought, you test at method level, you're looking for 100% code coverage. That's what you would do. I've not worked in safety critical areas, but I've imagined the kind of testing that you would need to do at that level, and assumed that would be the best practice that we should all be reaching for.
There is an issue with safety critical systems because in TDD, you're looking at testing the actual requirement that you've actually got in front of you, the use case, the story, whatever you want to call it, and doing the validation on that behavior. In a safety critical system, you're having to trap the side effects, which is the interaction between those requirements, which is not really what you're testing in the BDD or TDD environment. That's coming into more the system level and the higher complexity of the system.
And nothing stops you basically layering on, classical testing on top, right? If you think the TDD is valuable to write the first version of the code, that's great. But I would say TDD is useful, but it's not sufficient. And part of my problem is that people try and express many of the other requirements as TDD-like requirements, and it's just like, why not just call it test automation, and do what level of test automation you think is appropriate given your level of risk, your what happens if this goes down right in production when I deploy it. How much of a problem is that? How much additional testing on top of TDD do I need to make sure that's not going to happen? But those, I think, are overall risk questions, not questions for TDD as a practice.
I think that's the thing that gets missed a lot of the time. People seem to see TDD as being a testing mechanism. It's not, it's a design mechanism. Testing is a whole other area.
Yeah, you know, TDD proves your design works and keeps working, right? It doesn't necessarily prove that everything you need to basically have is there in order to basically deploy successfully. I mean, if your TDD stuff is failing, you're not going to deploy successfully. But there may be other stuff you need to do in order to deploy beyond your TDD test being green.
And that's where testing teams can actually put the value add in of doing the
right
non-functional testings of scalability, loading,
right.
resource requirements.
And contract testing, all those things are still good, right? All those things are still good and still give you value. You need to decide what balance you want. You know, you can, some teams are effectively, hey, we don't care. We're just going to basically do observability in production and we'll determine any of those other failures and we're fine with that. Other teams are, that can't work for us. And it's the classic problem of risk, right? You know, how likely is it to break? What's the impact of it breaking? What's the cost of us making that not happen? Is the cost of that greater than the cost of effectively actually the downtime we get if we could just redeploy again 2 seconds later? So yeah, it's a bigger question, and TDD shouldn't be trying to answer those questions.
Even I notice your virtual hand is also up as well.
Thank you. Cheers, Ian, for the talks. Really, really good to see your thoughts develop on this over the years. I do have a question around how do we move away from a mock-laden testing suite into something a little bit more reasonable?
That's a good question. So I think if I had one of those, what I would tend to do is figure out which of my dependencies I could move to just being newed up in constructors, because I didn't actually need to observe them. So I wouldn't start with, say, my database or file system and stuff like that, where there may be a speed issue and a shared fixture issue. I'd start with saying, where are some of these collaborations between classes? Where does class B and C only ever get exercised through class A? And from our API control, we exercise class A. Well, it looks like class B and C could be newed up, and it looks like probably we could lose their tests altogether because they should be covered as part of the original, right? That's where I'd start to look for my initial sweet spot. I mean, you can delete tests. You can throw them away and start again, right? And people get frightened about deleting tests because it's kind of like, oh, you know, they've got this investment in tests, but if tests are not helping, you just delete them. If I had that problem, I think I'd say, what is my API surface area at the top? What are the classes that are involved there? What are the dependencies of those? Are they dependencies that actually are brought under test by the test at this top level of the facade of the module? Great. Well, I could potentially new them up internally, check the test still works with me newing them up effectively and remove all the mocking. And then essentially say, well, do they actually need their own separate tests, or are they really just implementation details, a structure of that behavior?
Just let our code coverage tools kind of guide us when we've done enough eradication of the ISC container.
Yeah, right, exactly. And that's one of the side benefits of this process, right? We start to use dependency injection for what it's meant to be. And DI is one of these things that's got a bad name. And it's got a bad name because of this practice of the way we do testing, right? Everyone's like, oh, you know, inversion of control hell, etc. And that's only really true if you're injecting everything just to make it observable and test. If you actually say, I'm genuinely reserving that for layer boundary issues or runtime composition issues, then actually you need a lot less DI, and you can use quite simple DI containers.
Cool, thank you.
No worries.
So Jonathan had a question in the chat box. I get the sense that mocks are discouraged. If so, how do you verify side effects of non-pure methods?
I'd be questioning why you have side effects that you need to verify. Why is the observable behavior of this API producing a side effect that I can't monitor? If it's genuinely something I desire this API to do, why is that not something that I have a mechanism to monitor? Here's a cleaner example. Someone was asking me a little bit about a kind of CQRS system, right? Where essentially I have a command. That command effectively, when it gets implemented, results in a change to the data store. I don't see the result on that command. How do I test that? And the answer is, well, but how does your runtime code look at the results? My runtime code looks at the results by some query object that queries the data store and says, hey, that change is successful. Hey, results of that change mean I get these results now, right? So that's what your test is. It tests both. The test says, when I run this command and I follow up with this query, then I get these results out. Because that's the API you're genuinely testing. You're not testing one part of this API. Because that's just thinking about saying, I need to isolate this object under test, and therefore effectively I can't examine any of the side effects because that would be to look at two classes. It's not a problem. Your requirement is met by two classes. That's how you built your API. You built it in a CQRS fashion. There's a command and a query, run both. Right.
Jennifer has asked, have you got any suggestions for good BDD learning resources?
So I mentioned behavior-driven development, and I only really mentioned it in the context of Dan North's original observation. That early on in TDD's history, Dan pointed out that test may have been the wrong word to have chosen, and I think history's proved him right in the sense that we acquired baggage from unit testing, right? And over on the C2 wiki, people began to talk. People like Ron Jeffries began to talk about programmer testing or developer testing instead, and the community moved away from that term. As to BDD today, it's quite a different thing. It's almost kind of whole agile framework, and it's not something I've closely followed. I don't necessarily subscribe to BDD as a modern practice because it tends to focus a lot, or last time I looked, on acceptance testing tools, driving from the outside in such that you write your overall acceptance test and then small tests going down. So I wouldn't necessarily endorse BDD as a better way of doing TDD. I just note that BDD, Dan North, when he originally triggered what BDD is now today, had made this observation that we are testing the behaviors of the system, not implementation details.
So Matt has asked as well, could you expand more on your objections to having tests for enforcing coding standards, etc.? Is it just about those not being what testing is for, or is it about not focusing on enforcing code styles?
It's not what tests are for, right? The tests are about essentially capturing the user's acceptance criteria. I doubt that your genuinely real customer says to you, hey, I really care whether the developers are following this particular coding style. That's desperately important to me. What they care about is whether their software works, right? And it's the wrong mechanism to use to say, hey, the senior dev's going to sit down with you and express some structural requirements in the form of tests. And part of my problem is that these things you change your mind on, right? If I look at code that I wrote even 6 months ago, I may look at an absolute horror and go, what was I thinking, right? Hopefully I'm learning continuously enough that essentially I may go, well, that isn't the right way to do those anymore. I've learned more about that now. If I've baked that structural decision into my tests and said, we're always going to write stuff this way, it's a lot to unpick. I've worked at organizations where we made decisions about how transactions are going to be enforced and that kind of thing, which we later regretted. We said, that's not the way to do it. So you have to unpick all the tests at the same time. So I think it's just remarkably arrogant to assume that I can bake coding standards into tests to force upon junior developers that will essentially be true. And there are better ways of doing it, right? Training, everything else, much better way of solving those problems.
Are there any more questions? I think I've made my way through them. I don't know. Stuart, is that your real hand up, not the virtual one this time?
Well, the virtual one didn't. And that was really enjoyed the talk, and it was really good to hear. The reason I joined.
You're a bit quiet, Stuart. I can't really hear you.
Oh, can you hear me now? I'm moving a bit.
You got a mic you can lift up to your mouth.
Yeah, unusual. I'll shout loudly if that's all right. Can you hear me?
Hang on, I'll turn my sound up. Nobody else shout. You're deafening me.
Sorry, normally it's
all right.
So my quick question really is, a lot of what you've talked about actually reinforced a lot of the lessons that I've learned over the years. But what I found as I've kind of moved away from the coding myself and work with the teams around me, a lot of the arguments are the TDD is too difficult up front. Obviously, so therefore the argument is if they've got good test coverage at the end, then it's okay. But a lot of stuff you've said today reinforces it. So obviously, partly I invited them all today on the session, and some of them have joined you. Are there any alternatives that other than TDD that we should be looking at, or should we be doubling down on TDD as actually a really good practice that we should be following?
It's a great question, right? I think the only answer to that is TDD is a technique. I think for a number of people, TDD works as a practice and a way of doing stuff. And I think that it's sufficient numbers. I can't remember what I was trying to have a look at it, but I ran out of time, to what the Accelerate team has said about TDD as a practice, but that's one place to look. I think that generally the resistance to TDD has been around the complexity we cause with the unit testing model. And that when people go back to what TDD was first for, it's generally useful for people as a way of writing code. If your entire team sat there and said, we don't want to do TDD, we hate it, right? Then it's probably not worth forcing it on them. But the question you then have to answer is, how do we verify the things that TDD gives us? How do we design our code? What's our design strategy going to be? How do we make sure that we're not implementing code that isn't needed by the requirement? What's the strategy going to be for that? How do we verify that when we change stuff that we won't break existing requirements? So I think the question is, can you put in practices that replace the ones that TDD gave you? And if they work better for you, that's great, right? TDD gives you some things in return for making some choices. If you hate it, find something that gives you the same set of solutions.
Thank you. So I did realise my mic was too low, so hopefully I'm not deafening you now.
Okay, cool.
Okay, any more questions? Or
Yeah, I have another, if that's all right, Ian, if we're not taking too much of your time.
Come on, man.
I was very struck by your comment. You said a couple of times that the API is too coarse as a potential, and I think that may well be our problem in many cases. That we write a lot of kind of business management software, so we have a lot of, say, a goods in process that will take a list of stock that's been received from another system, and then that's creating stock lots and changing purchase order allocations to sales allocations, updating people, updating users that stuff is ready to ship, and as far as the incoming system is going, the kind of external API to all of this is give us some goods in data, and this stuff is all wrapped up in a transaction. So as much as is possible, it's a kind of all or nothing type of approach. So I struggle with how, I feel like that's the wrong design, but I struggle with how better to design that, because I want to reduce its kind of scale to make it simpler to test, but I don't want to lose the kind of transactional functionality. And it's not up to the external system to have an awareness of how those pieces are wired together. The running order of that is a function of our system, not theirs. So I don't want them to have to call 4 API endpoints. Do you have any kind of good pointers for that sort of design, or places to go and learn about it?
Sure. I mean, what I would look at is, remember that you're dealing with the kind of use case boundary inside the controller model. So what you receive as an input might spark a number of actions inside your use case. You might have separate use cases for many of those things. Your controllers are effectively orchestrating and saying all these things need to happen, all right? You can use things like events internally where you're saying, I'm going to update one kind of aggregate here. That all needs to be consistent. And I raise an internal event over an internal bus, and basically just in memory, it doesn't have to be between messaging systems. That'll then trigger an event over here. If this one fails, maybe I have something that says, well, what happens if that fails? Do I need to essentially say, well, raise an exception, I can reverse that initial transaction? So you might need to break it up a bit. I would look at whether you genuinely think, just because you are sent one input externally, whether or not that requires you to have one single action internally, or you actually think of it when you talk about it internally as a team as a sequence of things that you do, just protected against basically failure by saying, if one of those parts fails, I need to revert, and actually just codify that workflow. And you can run that in the controller. You can have a little test that says, call this thing that runs my workflow, if you like, and make sure it actually issues these relative commands.
Yeah.
And then essentially in response to all those individual commands, have a smaller API that says, I want to deal with that issue.
And then so there's your poor man's DI effectively is in that kind of unit of work controller that's driving those points that so you don't need you don't really need an inversion of control container there, because you're kind of feeding in your 4 stages or whatever your stages are, or your commands if you're in CQS, and then just letting those commands run.
Yeah, so you might from your beginning say, I know that when I get this control response, I'm going to call this class whose job is to issue 6 commands, right? And I'm just going to check it issues the 6 commands in this test,
right.
and I write some tests for how I handle the commands. So you can do that. You're essentially saying, I've got a very coarse-grained API, and I'm using it to call the other thing. I mean, I would focus a little bit on writing my TDD against those commands, right? And at the end, there's subparts. And at the end, say, I'm going to need some kind of test that checks that those 4 commands are actually issued in response to the call at my controller level, right? And I can automate that in a TDD-like fashion. Maybe that would be great, or maybe I can't, in which case, essentially, I'll rely on some other kind of automation to get that to work. But yeah, that's essentially what I would do, is suggest that at my controller level, what I was receiving was too big, and try and break it up into a series of things that I would sequence, and then figure out whether breaking it up into that sequence is also something I can test.
Yeah, so you need some sort of, whilst you're trying to test the kind of public-facing API view of the world, you need to inject some pragmatism yourself into just breaking this stuff and making it manageable.
I'd say, in my use case API, it may not necessarily be my external API, right?
Yeah,
my use cases that drive the entity model, I might have multiple of those triggered by a single external API call, because I'm constrained by talking to some vendor or whatever, effectively, right? And then I've got 2 tests. One is, what's my internal use case API? That's where I'm driving TDD. And another test that says I need to check that I can translate between that external thing and my internal thing. Because my test can drive all those separate commands, right? But actually, when it comes along, it's basically, I need to know it issues all 6 of those correctly with the correct form. Fine, I can write a test about that thing as well.
Brilliant, thank you. That's really helpful.
There's another one in the chat box as well, Ian. Say you have a simple system for handling, say, sales orders. You're asked to implement the next use case, cancelling a sales order. Where do you start?
So I think I'd first understand the requirement in a given when then sense, right? Which says, given that I have a sales order with blah, blah, blah inside it, when I cancel it, I expect the following things to happen. So say, for example, I don't know, that we charge our customers if we've already been more than X many days into implementing that order, because we may have built stuff, etc., effectively, or they've got a deposit, which we basically need to decide they lose after a certain number of days, etc. So I'd figure out what their requirement was. I then might write what's called a test list, which essentially is just in Markdown file or text, just literally what are the things that I probably want to test. So I'd say, well, I probably want to check that when I cancel an order and then I do a query against current outstanding orders, it no longer appears in the current outstanding order list, right? And that might be my first test. I might even say, well, actually, the first thing I want to check is that I can create a cancellation. It may be that a cancellation is a set of parameters and an object itself that I pass across. I could even start there and say, what does a cancellation look like? What data does it have on it? I'm going to create a test that says I write a cancellation, it has the following data in it. I can new up one of those and I can check it's got these things I need. Right, okay, great. Now I understand what a cancellation consists of. Now I'll pass it to something that says, do the cancellation process. But really the first step is always to understand the requirements. That's what TDD is driving you to do. It's basically say, what is the requirements? When I cancel something, what happens? You just not appear in the order list? Do I need to notify another system? Do I mark it as cancelled? Do I delete it from database rows? I'll probably mark it as cancelled rather than delete it, right? So I need to check essentially that after cancellation, it appears as cancelled, which means I need to set up a test data builder for the test that says, here's an order, right? I mean, you can even write first test if you've not got one that says, hey, the first test is that I can see an order if I've added it. Presumably you've got one of those, but if you haven't, you write that test first, right? And then you go away and then say, what happens if I cancel it?
I think we've got one more by the looks of things. Ian, do you think it will be easy to do TDD without good knowledge of practices like clean architecture or domain-driven design?
Oh, that's a good question. I think it
It's quite possible, yes, but you end up reinventing, I think, a lot of clean architecture. So because you need to test, I mean, so clean architecture, well, if you look at my clean architecture talk, one of the things I talk about is how it's just a variation of a classic UI presentation layer, then talks down to domain layer, then talks down to infrastructure data layer, right? And that quite often we divide that domain layer into a service layer and an entity layer. And that clean architectures really are the same. They just basically, rather than depends downwards, it depends inwards, right? So they treat the infrastructure and data and the UI as all the same. So if you had a classic layered architecture, you could certainly do TDD against the use case boundary, it would still work. So you don't have to have clean architecture, but you do want understanding of layering a little bit, and the notion that you're writing against some kind of facade over implementation details. But that's more OO stuff, right? So I think it's okay to not to have to do that before. Domain-driven design, I think that domain-driven design is valuable, but it is not necessary in order to do TDD correctly. It tells you all those domain-driven design patterns are useful, but they solve given problems. Like aggregates really about solving the problem of too many locks in a relational database. That's generally what it was built for. And it's solving a very specific problem, and you can take that and it's useful to you, great, but it's not a prerequisite to doing TDD successfully.
Okay, brilliant. Well, thank you very much, Ian, and thank you everyone for attending. We have recorded the session and it will be sent out towards the beginning of next week. We'll put it out on our LinkedIn as well as send it out to email addresses as well. And we have got a little feedback survey, which if you guys could give us your thoughts, that would be great. Just a reminder that we have got another TDD event on Tuesday next week with Layla Porter for .NET Oxford. And we're also hosting John Skeet September the 3rd as well. Details for that one will be announced over the coming weeks. But yeah, as always, if you've got any suggestions of topics or speakers or anything you would like to know, just get in touch. And yeah, thank you very much for attending.